Hey everyone, welcome back. This is lesson 5, complex numbers and roots. Your objectives for today, you're going to be able to define and use imaginary and complex numbers. You're going to be able to solve quadratic equations with complex roots. The vocabulary for today, imaginary unit, imaginary number, complex number, real part, imaginary part, and complex conjugate. You can see in the graph of f of x equals x squared plus 1, shown below, that f has no real zeros. If you solve the corresponding equation, 0 equals x squared plus 1, you find that x equals plus or minus the square root of -1, which has no real solutions. However, you can find solutions if you define the square root of negative numbers, which is why imaginary numbers were invented. The imaginary unit I is defined as square root of -1. You can use the imaginary unit to write the square root of any negative number. All right, imaginary numbers. An imaginary number is the square root of a negative number. Imaginary numbers can be written in the form bi, where b is a real number and I is the imaginary unit. The square of an imaginary number is the original negative number. So let's look at it as in numbers. If I have this thing right here, the square root of -1, it equals I, okay? So this is a thing that I always just remember. Square root of -1 equals I. So how does that look? If I have this equation, this piece right here, negative square root of 2, or the square root of -2, is the same as square root of -1 times square root of 2. Okay, and so since I know that square root of -1 is the same as I'm just going to say I square root of 2. So the square root of -2 is equal to I square root of 2. All right, here's another one to try. Square root of -4. Well, what we do is we take it apart and have it square root of -1 times square root of 4. Remember, -1, square root of -1 is our I, and then the square root of 4 is 2. So there's your answer. All right, what about this type problem? If I have the square root of -1 squared, well, that would equal I squared. Okay, so what does I squared look like? Okay, well, I is square root of -1 times square root of -1. So that would be the same as -1 times -1. We have two of them in there, so that actually equals just -1. Okay, and I'm not going to do it in the algebraic terms, but you can look at this. If b is a positive real number, then the square root of -b equals I times the square root of b, and so on. That's just using it in letters. Let's look at our first example. The instructions tell us to express the number in terms of I. So all we need to do is first factor out -1, and all that means is we're just going to rewrite our problem to look like square root of 121 times -1. All right, and then we're just going to separate it into two separate square roots. So 5 times square root of 121 times the square root of -1. So now we know that that -1 is going to be an I. So we're going to simplify. So we know the square root of 121 is 11. And then we have our square root of -1, and we know that is going to be an I. So in the end, we have 55 times square root of -1. And then now to express it in terms of I, 55I. So hope you could find that pretty simple to follow. Let's try another one. Okay, here we have express the number in terms of I again. So the first thing we want to do is factor out our -1. So rewrite it like that. Our next step is just separate it into two separate pieces. 96 is the same as square root of 16 times square root of 6 times the square root of -1. Okay, and so next we're going to simplify that. Square root of 16 is 4. There's nothing, we can't break our square root of 6 down anymore. And we're going to change this -1 now to an I. So there we go. So it's going to be -4i times the square root of 6. I think that's pretty easy for you, so let's just keep on moving on. All right, we can use this rule once we start trying to solve equations. So if we have x squared equals -144, we can take the square root of both. So do our square root, and that's how we got that. So that leaves us with x equals plus or minus. And now we just do what we were doing before. This is going to be 12i, and so there's our answer, just x equals plus or minus 12i. And then, of course, we could go back and fill it in and check it and see that it is correct. Okay, here's another one. So think about what you would do on this one. The first thing that we should do is just move our 90 to the other side. So we're going to subtract 90 from both sides. Okay, so we're going to add 90 to both, -90 to both sides. So we end up with 5x equals -90. All right, now we need to divide both sides by 5. Divided by 5. And we get x squared equals -18. So next we want to take the square root of both of those. And there's our final. And then we need to express it in terms of I. So -18 is the same as 9 times 2 times -1. All right, and 9 is a 3. That's where we get our 3. And the square root of -1 is our I, and then we have the 2 left over. All right, and then of course you can check that. Okay, now a complex number is a number that can be written in the form a plus bi, where a and b are real numbers and I equals square root of -1. The set of real numbers is a subset of the set of complex numbers. So when we first started working, we've only been working with real numbers, and now we're going to be working with real numbers and imaginary numbers. Every complex number has a real part, the A, and an imaginary part, which is going to be our B. Real numbers are complex numbers where B is equal to 0. Imaginary numbers are complex numbers where A is equal to 0 and B is not equal to 0. These are sometimes called pure imaginary numbers. Two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. Let's look at this example. Okay, 4x plus 10i equals 2 minus 4y times I. And it says what? Find the values of x and y that make this equation true. So the first thing we want to do is go ahead and write our equation down, and we need to pick out which ones are the real parts, and those are going to be our 4x and our 2. And then which parts are going to be our imaginary parts? That's the 10i and the 4yi. All right, there they are. So next we want to write them out as equate the real parts. In other words, set them equal to each other. So 4x is going to equal 2. So when we solve for x, we find that x equals 1/2, just divided both sides by 4. All right, and then we're going to go ahead and do the same thing with our imaginary parts. So we're going to say 10 equals 4y. Divide both sides by 4. And we end up with -5/2. So now we have figured out that when x is 1/2 and y is -5/2, we have a true statement. This example says find the zeros of the function. So the first thing that we want to do is set this equal to 0. All right. So once I have it set to 0, I'm going to see if I can factor first, just easily. And so I'm going to look at my 26, two numbers that multiply together to get 26, add together to get 10. I can't think of anything right offhand, so I need to rewrite my equation, and I'm going to rewrite it so that I can complete the square. So don't forget, we learned how to complete the square. So I'm going to set it up with 2 extra blanks in there, and remember, when I want to complete the square, I'm going to add b divided by 2 squared. So my b is 10, so I'm going to say 10 divided by 2 equals 5. And 5 squared equals 25. So I'm going to add 25 to both sides. Now when I do that, I can now factor this out. 2 numbers that multiply together to get 25, add together to get 10 is going to be x plus 5 times x plus 5. Or in other words, x plus 5 squared equals -1. The next thing we do is take the square roots of both sides, square root and square root, and now I end up with x plus 5 equals plus or minus the square root of -1. All right, so I want to just simplify that, so let's just subtract 5 from both sides, minus 5 from both sides, and I end up with x equals -5 plus I, this negative square root of 1, or yes, square root of -1 is equal to I. Here's another example to try. Again, we're going to find the zeros of the function. So the first thing we want to do is set our equation equal to 0. And when we do that, let's just check and see if we can really quickly factor this. 2 numbers that multiply together to get 12, add together to get 4. I can't see how that could work. So I'm going to have to rewrite it so that I can complete the square. So there I have it in that order. And remember, when I'm going to complete the square, I'm going to take b divided by 2 and then square it. So in this case, b is 4. 4 divided by 2 equals 2, and I'm going to square that. So I'm going to add 4 to both sides of my equation. And now I can factor my equation. So I know that this is going to be x plus 2 and x minus 2. 2 numbers that multiply together to get 4 and add together to get 4. All right, and so I see that. The next thing I need to do is take the square roots of both of these. All right, and when I do that, I end up with x plus 2 equals plus or minus the square root of -8. The next thing I need to do is just simplify that. So let's subtract 2 from both sides, minus 2. And remember, square root of -8, let's just look at that, is equal to the square root of -1 times the square root of 4 times the square root of 2. All right, and we know that square root of 4 is 2. And square root of -1 is I, and so we're just left with the square root there. So once we simplify, we end up with -2 plus or minus 2I square root of 2. The solutions, -5 plus I square root of 10 and -5 minus I square root of 10 are related. These solutions are complex conjugate pair. It's a complex conjugate pair. Their real parts are equal. Their real parts are equal, -5 and -5 in this case. And their imaginary parts are opposite. Okay, so it's a -I square root of 10 and a positive I square root of 10. The complex conjugate of any complex number a plus bi is the complex number a minus bi. If a quadratic equation with real coefficients has non-real roots, these roots are complex conjugates. Sounds like a lot, but it's not going to be that much. When given one complex root, you can always find the other by finding its conjugate. All right, let's see how easy this is. So let's take a look at 8 plus 5i. The way we find the complex conjugate, we're just going to write it as a plus bi, and in this case, 8 plus 5i is already written in that form. So now all we have to do is find a minus bi, so we just change to a minus 8 minus 5i, and we've done it. So you can see 8 minus 5i is the complex conjugate to 8 plus 5i. Let's look at b. It's equally simple. The first thing we want to do is write it as a plus bi, and notice that I don't have an a, so I'm just going to fill in with 0. So it's 0 plus 6i. Now all I have to do is subtract instead of add. So 0 minus 6i, and simplify that, it's just negative 6i. So you can see it's really simple. We could have skipped those steps. Let's just do a couple of more. 9 minus I, again, we write it as a plus bi. So 9 plus a negative I. And then we just change it from plus to minus and simplify, and we end up with 9 plus I. So notice 9 minus I and 9 plus I is the complex conjugate. Again, let's look at b. Notice that the I is in the first place here and the square root of 3 is in the second, but we want to write it as a plus bi. So let's just rewrite it to square root of 3 plus I. Again, we just have to subtract now. So square root of 3 minus I is going to be the complex conjugate. All right, looking at 8, again, we want to rewrite it as a plus bi. And notice that we don't have an a again this time, so we're going to change that to 0 plus a negative 8i. And now we just have to change our addition sign to a subtraction. And there that is, and then simplify, and we end up with 8i. And you probably could have predicted that negative 8i, the complex conjugate, would be 8i. All right, that's all we're going to do for today, and I hope you have a great day, and I'll see you soon. Bye.